Hey folks, in this next video here, we're going to talk about combining capacitors together. I've drawn a quick sketch of one combination of capacitors. I've put C1 next to C2 and I've hooked them up to a battery. If you would take a moment to copy that diagram down, that'd be great. All right, so this combination is called parallel. And what that means is if you're an electron traveling through this battery, so you're an electron and you got let's say taken off that plate right there, and so here you are and you're going through the battery, right? Okay, you have a choice on where to end up. So maybe you'll end up on this plate. But then the next one that travels might come off of that plate and end up on that plate. So these are what we call parallel. You have a choice. You could either come off of C1 or come off of C2. So parallel is an or statement. Okay. Now, we're going to figure out the total capacitance of this system in terms of C1 and C2. Now, a couple things we should know. Notice that they're both hooked up to the same battery. So the voltages of 1 and 2 have to be the same. So V1 has to equal voltage 2. Okay. I also know, like, let's say you get 3 charges off that, and let's say you get 5 charges off that one. Okay. I know that the total charge that traveled through that battery down there is equal to the charge that moved through C1 plus the charge that moved through C2. So what we can write is we can write Q1 plus Q2 is the total charge that moved through the battery. And this is what we're interested in. We want to know what's the equivalent capacitance of these two capacitors put together. How much total charge can we move for the given voltage? Now, Q is equal to CV. So this becomes C1 V1 plus C2 V2 equals this capacitance equivalent of your two capacitor system, V. Okay. Now the voltage V1 and V2 and the battery voltage, they're all the same. So these V's cancel. And so, hey, your C equivalent is simply equal to C1 plus C2. That's it. So when you have two capacitors in parallel, you just add their capacitances together. That gives you your equivalent to EQ capacitance. Now, a side note, in the previous video, we talked about for parallel plate capacitor, I'll use that as the example. For a parallel plate capacitor, capacitance equals epsilon naught A over D. Okay. Well, let's say you started with C1. So here's C1. And then let's say you then added C2 to your system. Well, what have you actually done? Well, you basically increased the area, right? Instead of having just, I'll do it in blue here, instead of having just this area, well, now you have the area of C1 plus the area of C2. You just added area to your system. So when you add capacitors in parallel, you increase the capacitance. You make it easier to move electrons from one side of the battery to the other. Okay, so that's parallel capacitors. Now, by the way, note for those of you who have done electric circuits in the past, you may have talked about resistors. Resistors do the opposite thing. When you add resistors in parallel, resistance actually goes down. We'll be talking about that in the next unit. Okay, so capacitors and resistors in that respect, they behave oppositely. So just keep a note on that. So just as a reminder. All right, now how about if you put the capacitors in series? So series looks like this. You've got one capacitor, we'll call that C1. Right after the other, we'll call that C2. Okay, and then you're going to put your battery down here like so. Okay, there we go. Your battery has some voltage V. Okay, so what's the total capacitance of this system? Okay, and has it gone up or down? Well, here's what we know. Let's say you pull off 3 electrons, boom, 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 off of the right-hand plate of C2. So you're left with 3 positives there, right? Those 3 electrons go flying through your battery, and they end up boom, 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 depositing there. Well, those 3 electrons are going to knock 3 electrons off of the right plate of your capacitor 1, okay, leaving behind 3 positives, and those electrons will deposit themselves on the left plate of C2. Okay, so some things to notice here. What do you notice about Q1 and Q2? Well, they're both 3. So it turns out that when capacitors are in series, Q1 are the charges are equal. Q1 in this case equals Q2. Also notice, let's say that this were, for instance, a 10-volt battery. Okay, voltage is like electrical height. Okay, so if the electrons move through 10 volts of height, when they go through C1 and then C2, they have to lose that 10 volts of height. That means that these two voltages added together is 10 volts. So we've got V1 plus V2 equals our total battery voltage. Okay, now remembering that capacitance is Q over V, or if I solve that for V, V is equal to Q over C. Okay, I'm going to use that here. So this becomes Q1 over C1 plus Q2 over C2 equals the total charge that moved through the battery divided by the equivalent capacitance. But remember, the Q1 and Q2 and the total charge are all the same. The 3 electrons or 3 negatives that came off the right plate of C2, those are the same 3 negatives that went through the battery and deposited themselves on the C1 over there. So all the Q's are the same. So the Q's drop out and you get the following. 1 over C equivalent is 1 over C1 plus 1 over C2. So for series capacitors, you add the reciprocals of their capacitance to get the reciprocal of the total capacitance. Now, as a consequence of this, if you add capacitors in series, you actually drop the capacitance. You actually make it less. So for instance, let's say these capacitors were each 4 microfarads, for instance. So one capacitor would have a capacitance of 4 microfarads. So what about 2 of them? Well, 1 over 4 plus 1 over 4 ends up being 1 over 2. You flip it over, you get 2. So if I add 2 4 microfarad capacitors in series, the total capacitance is only 2 microfarads. So by adding capacitors in series, you're reducing capacitance. Also, imagine your parallel plate capacitor equation. C equals epsilon naught A over D. Well, by adding C2, what have you actually done? Well, you've just made the distance farther from the far left-hand plate of the system to the far right-hand plate of the system. You make D bigger. If you make D bigger, capacitance drops. Okay, so that these charges don't like being squeezed together so much. In the next video, I'm going to do an example, actually 2 examples. One is going to be a combination capacitor circuit, and the other one is going to be, we're going to play with a couple of capacitors and try some stuff out. Okay, so again, series or parallel, when you just add the capacitors together. Series, you add the reciprocals together to get the reciprocal of the total capacitance. All right, hope that video was helpful, and thank you very much.